In a surprising turn of events, NASA's James Webb Space Telescope has made a groundbreaking discovery. Astronomers are now aware of a finding that left the world in awe. A few weeks ago, the telescope discovered the earliest known galaxy in the universe. But now, it has detected something even more massive, a supermassive black hole moving away from its galaxy at an incredible speed of 4 million miles per hour. This latest discovery has implications that are extremely significant and has generated much speculation among scientists and space enthusiasts about what it means for our understanding of the cosmos. The James Webb Space Telescope was launched on a mission to explore the first stars and galaxies in the universe and has captured stunning images of the death of stars and galaxies from a few 100 million years after the Big Bang. We invite you to join us to explore the latest discoveries from this telescope. Remember to like and subscribe for more content like this one. The latest discovery is challenging the scientific community's current understanding of black holes. Black holes are generally thought of as huge entities that pull everything, including light, toward them. However, the recently discovered black hole appears to be having the opposite effect. Instead of absorbing light, it is creating new, young stars along a long trail. This new trail of newborn stars has been observed in the wake of the black hole, which stretches an incredible 200,000 light-years away. Scientists are puzzled by the unusual behavior of this black hole compared to others, but a team led by geoastronomy Professor Banda recently reported their findings in the astrophysical journal Letters. NASA's Hubble Space Telescope additionally supported these observations, suggesting that the black hole awakens new stars when it comes into contact with gas and cools it. We are seeing the wake behind the black hole. But that's not all. NASA has made an exciting announcement about the galactic merger ARP-220, which was captured by the James Webb Space Telescope. This impressive galactic merger can be seen shining among the constellations of the night sky's galaxies. When two spiral galaxies merge, the phenomenon known as ARP-220 shines brightest in the infrared, making it perfect for observation by the James Webb Space Telescope. It is classified as an ultraluminous infrared galaxy, with a luminosity of 1 trillion suns, compared to our own galaxy, the Milky Way, which has a much lower luminosity of about 10 billion suns. ARP-220 is located in the constellation of Serpens, about 250 million light-years away. It is regarded as the brightest of the 3 closest galactic collisions to Earth, and it is listed as the 220th object in the Atlas of Peculiar Galaxies. About 700 million years ago, 2 spiral galaxies collided and triggered a huge explosion of star formation. This created a dense region about 5,000 light-years across that contains about 200 large star clusters. Surprisingly, this small area contains as much gas as the entire Milky Way. Previous observations with radio telescopes discovered about 100 supernova remnants in less than 500 light-years across. Then, the Hubble Space Telescope revealed that the galaxies are located 1,200 light-years apart and that each core contains a rotating ring of star formation that emits dazzling infrared light. The latest views from the James Webb Space Telescope show an impressive galactic merger of the two galaxies. This image also shows tiny tails of tidal material sticking out from the outskirts of the merger, indicating the gravitational pull between the two. Finally, the red, ochre, and orange streams and filaments represent scattered organic materials in ARP-220. Another stunning discovery stumped scientists when researchers found primordial galaxies at the edge of the universe. They were skeptical about their authenticity. Some thought they might be nearby galaxies in disguise. So they shared the data with other scientists around the world, hoping for the best. Amazingly, the James Webb Space Telescope confirmed that these ancient galaxies are real. Thanks to this revolutionary telescope, we can now observe the earliest known galaxies. Astronomers estimate that light from these galaxies has traveled more than 13.5 billion years to reach Earth, giving us a glimpse into the distant past of the universe. These galaxies were discovered when the universe was young, which sheds light on how quickly the first generations of galaxies emerged. The spectral data confirmed that these galaxies, some even farther away than Hubble could see, are real. The discovery is crucial because it validates one of the most important tasks of the James Webb Space Telescope, to study the early universe through the moving light of the past. For more than 13.5 billion years, the ability to measure extreme redshifts is what sets James Webb apart, allowing astronomers to peer into the infrared range and observe the first galaxies in the universe. The excitement in the air is evident because this discovery signifies an important milestone in space exploration. As more data continues to pour in, astronomers are already planning follow-up observations. The James Webb Space Telescope, with its advanced infrared capabilities, has opened a new window into the early universe, one that reveals far more than we ever imagined possible. The implications of these discoveries go beyond just astronomy. By understanding how galaxies and black holes behaved in the early universe, scientists hope to unravel the very processes that led to the formation of stars, planets, and possibly even life itself. The detection of a supermassive black hole generating stars rather than consuming them raises profound questions. Could there be more such anomalies? Is our current model of black hole physics incomplete? Are we standing on the edge of a new era in cosmic understanding? The Webb telescope's ability to peer deeper into the universe than ever before is already rewriting textbooks. What were once theoretical speculations are now being confirmed by actual observation. As researchers analyze the trail of stars behind the runaway black hole and the fiery heart of ARP 220, theories about galaxy evolution, dark matter, and interstellar gas behavior are being put to the test. Moreover, the international collaboration around Webb's findings highlights a new kind of science, one that is shared, reviewed, and expanded upon globally in real time. As discoveries are confirmed and peer-reviewed, educational institutions and scientists around the world are gaining access to unprecedented insights that are reshaping curricula and inspiring the next generation of space explorers. But perhaps the most awe-inspiring aspect of all is philosophical. When we look into the ancient light captured by Webb, we are not just witnessing history, we are witnessing our own origins. Every particle, every atom, every molecule that makes up life on Earth was forged in the heart of a star. By studying the birth and death of these stars, we are ultimately exploring the roots of our own existence. As the telescope continues its mission, one thing is certain: the universe still holds countless secrets. And with each new image, each new spectrum, and each new discovery, the James Webb Space Telescope brings us closer to understanding the vast, mysterious cosmos we call home. Of the universe, and in understanding its evolution, the discovery has had a major impact on our understanding of the universe and has prompted NASA to develop even more powerful telescopes than the James Webb Space Telescope to confirm whether our understanding of the Big Bang is correct. Data obtained from Webb's F spectrometer and near-infrared camera have revealed that 4 of the 6 primordial galaxies have extreme redshifts, suggesting that Webb is observing them as if they existed 300 to 500 million years after the Big Bang, without heavy elements such as carbon. This is surprising, since the universe is estimated to be 13.8 billion years old, and the existence of these galaxies suggests that we need to revise our understanding of the early universe. This has generated concern in the scientific community, as these new discoveries challenge the current cosmological inflation model and the Big Bang theory, which has some loopholes, such as going against the law of thermodynamics and not having a clear explanation of what caused the Big Bang. In addition, the James Webb Space Telescope is discovering galaxies almost as old as the Big Bang itself, which questions everything that we thought we knew about the origin of the universe. As it appears, theoretical physicist Michio Kaku stated that the discovery of ancient galaxies by the James Webb Space Telescope has called into question everything we knew about the beginning of the universe. Before, these galaxies were thought to be less developed than the Milky Way, but the new findings suggest that we may be missing crucial information. The fact that the telescope has identified 6 galaxies that existed 500 million years after the Big Bang, and are up to 10 times larger than the Milky Way, raises the question of whether our current theories about the creation of the universe are correct. Kaku explained that it takes billions of years to create a galaxy like the Milky Way, so it is strange to find such large, young, primordial galaxies. This discovery may require us to revise and rewrite the textbooks about the beginning of the universe. Findings from the James Webb Space Telescope challenge what we thought we knew about the Big Bang, leaving scientists at a crossroads. Despite this, NASA recently tweeted about a galaxy cluster that lies just 650 million years after the Big Bang, adding another fascinating component to the puzzle. Astronomers have analyzed the data and concluded that this fledgling cluster is anticipated to expand and become something similar to the colossal Coma A1656 cluster. The place where all this is taking place is unique and special, as it is in an area of accelerating galactic evolution. Thanks to the James Webb Space Telescope, researchers can now measure the velocities of these 7 galaxies, which gives them the confidence to confirm that they are bound together in a protocluster. To put this in perspective, NASA scientists compared these distant galaxies to small drops of water in different rivers that will eventually join together to form a large, powerful river. Clearly, what we previously believed about the Big Bang is not adding up as expected. However, more data from the Webb telescope may reveal evidence that could confirm or disprove the theory. Who knows, maybe the Big Bang did happen, but what caused it is a different story. In any case, we will have to wait for more discoveries. But we may be wrong about the answer. What do you think about these discoveries? Share your thoughts in the comments box, and I'll see you in the next video. Thank you so much for watching. As more data pours in from the James Webb Space Telescope, the boundaries of what we thought was settled science are being pushed further than ever before. With each new image, each spectral analysis, we're not just observing ancient light, we're witnessing the unraveling of our oldest assumptions. Scientists around the world are now re-evaluating the timeline of cosmic history. If massive galaxies could form so quickly after the Big Bang, then either the process of galaxy formation is vastly more efficient than previously believed, or the Big Bang itself may need to be reinterpreted. These aren't just abstract concepts, they affect how we understand our very existence. The early formation of such galaxies could imply the presence of forces or particles we have yet to discover. Perhaps dark matter or dark energy played a far more significant role than we imagined. Or perhaps there's a fundamental flaw in our models of time and space. And this is just the beginning. The Webb telescope is expected to continue sending back high-resolution data for years to come. We may discover ancient stars that predate current theoretical limits, or find structures that suggest an even earlier phase of the universe, one we have yet to conceptualize. As one astrophysicist put it, we are not rewriting a chapter. We're rewriting the entire prologue. So, stay tuned. The universe still has secrets to tell. And with every pixel of light captured by the Webb telescope, we get one step closer to the truth, whatever that may be. Thank you for being part of this journey. Don't forget to like, subscribe, and turn on notifications so you don't miss the next cosmic revelation. Until then, keep wondering, and keep watching the stars.